All right, boys and girls, we are on to lesson 10, module 5, and our objective for this one is that we are to use an area model and division to show equivalence of two fractions, just like we did yesterday, or on our last lesson, lesson 9. So what I'd like you to do first is I'd like you to draw an area model that represents 10/12. So go ahead and pause while you do that. Area model that represents 10/12. So you might have had something similar to this. I have to compose equivalent fraction. I want to compose an equivalent fraction. So what can I do? I need to bundle and put things into groups. So I could bundle them in groups of 5. Here's 5. Here's 5. Oh, wait. There's only 2 left. My groups have to be equal. I could do 4. 4 and 4 and 4. Well, I guess that would work. But I want my fractioned pieces to be together. These last 4, they weren't together. I could do 3, 3, and 3, and 3. Oh, but my filled in piece goes with these 2 empties. That doesn't work. The only one I can truly see is 2. So I'm going to bundle in groups of 2. Because that works out that all of my shaded in pieces stay together and my non-shaded in pieces stay together. So what happened to my 12 pieces? Well, they got smaller, didn't they? How many pieces do I have now? 1, 2, 3, 4, 5, 6. I have 6 pieces now. So I have to take my 10/12 and get to a new fraction. Well, what's my new fraction? 1 shaded, 2 shaded, 3 shaded, 4 shaded, 5 shaded out of 6. So I have to ask myself, how did I get from 10 shaded pieces down to 5 shaded pieces? Well, I grouped them by 2. So that means I'm going to divide by 2. And 2 is a factor of 10. Is 2 also a factor of 12? Why, yes it is. 10 divided by 2, does that give me 5? Yep. 12 divided by 2, does that give me 6? Yep. So I have proven that 10/12 and 5/6 are equivalent because of the common factor 2. What I do to the top, I do to the bottom. Let's take this a step further. Let's look at our denominators. What do you notice about 12 and 6? Well, if you said that 6 is a factor of 12, you're right. Let's look at our numerators, 10 and 5. Well, 5 is a factor of 10. So let's go ahead and list our factors of 10. Let's go ahead and do that. 1, 10, 2, 5. And that's it. Let's list our factors of 12. 1, 12, 2, 6, 3, 4. So I would ask myself, what do these 2 numbers have in common? I'm looking for that common factor, but I'm also looking for the greatest common factor. So obviously they both have 1 in common, but that's pretty small. And I couldn't divide by 1 and get a different answer. They have 2 in common, but I can't stop. I have to check them all. 3, nope. 4, nope. 6, nope. 5, nope. 10, nope. 12, nope. So the only factor they have in common is this 2. So this 2 is my greatest common in common factor. So that's why I truly divided by 2. Yeah, I grouped them by 2. But the reason I did that is because 10 and 12 have 2 as a common factor. I want you to draw an area model to prove that 6/10 equals 3/5, remembering to start with 6/10. Go ahead and pause this while you draw that area model. You should have gotten something like this, where I have 6/10 shaded in. And then I divided them into groups of 2. So I put together shaded, 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 not shaded, not shaded. Now if we were to look at our factors again, factors of 6 are 1 and 6, 2 and 3. Factors of 10 are 1 and 10, 2 and 5. If we compare them, there's no 10 up here. There's no 5. There's a 2. There's no 6. There's no 3. Obviously there's a 1. But if I divide 6 by 1, I still get 6. So my greatest common factor is a 2. The last thing I want you to do is I want you to create an area model that represents 8/12, but I want you to equal it to something. You can figure out whatever you want to equal it to, but it needs to use division, just like we've been doing. You need to group. So create an 8/12 area model. If you want to work with someone to create this, you can, or you can work on it by yourself. Good luck. Here's what mine looked like. I have 8 out of 12 shaded. And then I said, well, what factors do they have in common? And I came up with these as their factors. And then I just compared. I don't need to keep crossing off. I see they have 1 in common, 2 in common, and 4 in common. Well, which one's the greatest? Well, it's 4. So I'm going to divide by 4 this time. So I'm going to bundle them in groups of 4 because I want the greatest way. The 2 would work, but I want the biggest way. So that's just me. You may have chosen the 2, and that's okay. So 8 divided by 4 is 2. 12 divided by 4 is 3. So I have 2 shaded groups out of 3 total groups. 1, 2, 3. You might have also gotten this. You might have said 8/12, and you might have said, I'm going to divide by 2, because that's a factor they have in common. And you would have gotten 4, 6. And that's correct as well. Either one would have worked. So what can we say about 4, 6, and 2/3? Well, they are equivalent, because they both equal 8/12. And you can divide 8/12 by 2 or 4, because those are both factors of 8 and 12. All right, boys and girls, what I'd like you guys to do is I would like you to work on your problem set. Please find a partner. This is the type of work I should be seeing on your problem set. Don't forget those factors. They're important. Be thinking about those. Good luck.